Here is the question number 36. A uniform magnetic field is restricted within a region of radius 1 meter. The magnetic field changes with time t as B equals B naught 2t by 3 k cap. The loop of radius 2 meter is outside the region of magnetic field as shown in the diagram. The EMF induced in the loop is what? Now first of all, the magnetic field B is not in the region of given loop. It is confined to the region of somewhere of radius 1 meter. So in this loop there is no magnetic field. Present. Now therefore flux phi, as we know that B dot A, if there is no magnetic field then there will be no flux, then there will be no d phi by dt, and if there is no d phi by dt then there will be no EMF induced. So after getting this result we can say that our option number 1 is absolutely correct. We will go with option number 1. Now let us proceed to the next question, that is question number 37. In the given figure, the current I is flowing through the straight wire and divided equally in 2 loops as shown in figure. The magnetic field intensity at the center O will be what? Now first of all, we are having 3 wires, 1, 2 and 3. Now let's calculate the magnetic field due to the individual wires. First one, that is B1, is what? The magnetic field due to semicircular loop is given by mu naught I upon 4 times R. So mu naught I has the value I by 2 into 4 times radius is R2. Actually current is anti-clockwise, so the direction of magnetic field will be perpendicularly outward. Dot. Now similarly B2, the magnetic field in second current carrying wire will be given by, see, this is also a circular semicircular loop, so magnetic field will have the same expression mu naught I upon 4 R. So I has the value I by 2, 4 times radius is R1 here. Current is clockwise, so the direction of magnetic field will be inward plane of the paper. Now B3, magnetic field due to third wire. Third wire is infinitely long straight current carrying wire, and we have to calculate the magnetic field at one of its end. We have the formula mu naught I upon 4 pi R. So putting mu naught total current I upon 4 pi, the distance between point O and the wire is R1, which is again inward plane of paper. So the net magnetic field B will be given by, these two are in same direction and the B1 is opposite. So we can write B1 minus of B2 plus B3. Now let's put the values. B1 has value mu naught I upon 8 R2 minus of B2 has value mu naught I upon 8 R1 minus B3 has value mu naught I upon 4 pi R1. Now let's take mu naught I 4 pi common and see what we are going to get. In first, pi upon 2 R2 will remain. In second term, pi upon 2 R1 remains, and in the last term, that is minus, only 1 by R1 remains. So after looking at the answer, we can say that our option number 3 is absolutely matching with answer. So option number 3 will be absolutely correct. Now let us proceed with the next question, that is question number 38. So here is question number 38. The current sensitivity and voltage sensitivity of a moving coil galvanometer are 0.3 radian per ampere and 3 into 10 to the power minus 5 radian per volt respectively. The resistance of galvanometer will be what? We know very famous relation that the voltage sensitivity of a galvanometer will be current sensitivity multiplied by 1 by R. Don't think this as a potential difference. Don't think this as current. They are the sensitivities. It is not like V equals IR. This is voltage sensitivity of galvanometer equals current sensitivity multiplied by 1 by R. So from here we can get R equals current sensitivity divided by voltage sensitivity, which is current sensitivity is given 0.03 whole divided by voltage sensitivity is given 3 into 10 to the power minus of 5. Minus 5 goes at the top, becomes plus 5 and gives 10 to the power 3 divided by 3. That is 10 to the power 3. That is 1000 ohm. In short, 1 kilo ohm we can write. Option number 1 is absolutely matching with our answer. So here was question number 38. Now let us proceed to the next question, that is question number 39. So here is question number 39. The speed of proton increases in a cyclotron, then the value of specific charge will be what? Given that if the case is non-relativistic, means relativistic mass is not considered. Now we know very well that the specific charge is nothing but charge by mass ratio for a particle. Now we know very well that charge is non-relativistic in nature, means it does not depend upon the speed. On the other hand, it is already given in the question that relativistic mass is not considered, so this m will also be constant. Since q is constant, m is constant, so we can say that a specific charge is going to be constant. So we proceed with the first option. It will remain same. Now let us proceed to the next question, that is question number 40. Here is question number 40. B naught is magnetic field at point P for a given straight wire as shown in figure. If the wire is bent into a circular loop, then the magnetic field at the center of loop will be what? Now this is a straight current carrying wire of finite length, and we know the magnetic field due to such a wire is given by, in the question B naught, that is mu naught I upon 4 pi r, where r is the perpendicular distance between wire and point, which is L by 2 here. In bracket sin theta 1 plus sin theta 2, where theta 1 and theta 2 are these angles. Since this is L by 2, this is L by 2, this angle is 90 degree, so these two angles must be equal. That is 45 degree and 45 degree. So theta 1 is 45, theta 2 is also 45. So ultimately we get 2 sine 45 degree. After solving, we get the value of B naught as mu naught I divided by root 2 times pi L. From here we can get mu naught I upon L expression as root 2 times B naught pi. We need this expression in the latter part. Now this wire is bent in the form of circle, so we get current carrying circular loop whose radius can be obtained by circumference will be directly equal to length of the wire, and therefore radius of the loop will be given by L by 2 pi, and we know the expression for magnetic field due to current carrying circular loop at the center is mu naught I upon 2 times r, which can be further written mu naught I upon 2 times r equals L upon twice pi. 2 cancel out. We get expression for B as mu naught I pi whole divided by L, where mu naught I upon L we already have got. Therefore B equals root 2 times B naught pi square. So this is our final expression, and after observing the options we can say that option number 3 is Absolutely correct. So we will go with option number 3. Now let us proceed to the next question.